Okay, this is the first one of, our group in hydrocarbons. So another name of paraffins is aliphatic hydrocarbons. This table show you specifically what is the structure of different actually component of these paraffins, and also the name and properties at room temperature. Okay, so if we talk about methane, which is CH4, and also C2H, 6, ethane, propane, and N-butane, all of these, and also iButane, all of these are gas. And then we have from, carbon number of 5 to about, 17 are liquid. And then more than that, which is asphalt and other major component are, solid. Okay, so this is table is very, very important. Normally, if you want to do PVT analysis, you need to actually know about this component, and after that you will do simulation for pressure, volume, temperature for your liquid and your hydrocarbon. Okay, so what they include? They include alkanes. So when you hear about alkanes, you need to know that these alkanes all are saturated. Okay, and the general formula of these alkanes is CEng H2n+2. Okay, so methane, ethane, and etc. are what? All of them are alkanes. Okay, so, and also we have alkanes. Alkanes are unsaturated. So this one, this thing needs to be well understood, that we have these alkanes, which is unsaturated, and we have alkanes, which is saturated. And also, you need to know exactly the formula of each of these. So here we have alkane, which is saturated with the formula of CnH2n+2, and we have alkane, which is unsaturated, and the formula of CnH2n. Okay, so the carbon atoms are joined together to form chains. So these chains normally is, so here you can see some alkanes, not alkane. This is alkane and this is alkane, and you can identify and categorize this if we, bring this in, question or any type of, quizzes. So you just learn about these things and about the actually sequence of these paraffins. Okay, naftans. Okay, so these naftans are cycloparaffins. So they are composed of cycles, in the paraffins, and are also characterized by a carbon atom that joins in such a way as to form a ring. So as you can see, this one is this one. Actually, this is why we call it cycloparaffins. All of them are creating a ring. This is also a ring, C5H10. Okay, Cn2n. Also, this one is CnH2n. Okay, so this one is another paraffins. So the heavier MW. Okay, can you tell me what is MW?
Molecular weight.
Oh, good. Okay, the heavier molecular weight fraction of petroleum often contains quite complex naphthanes molecules with 2 or more rings joined together. Okay, so as you see from the top to below, the number of carbon increased. Subsequently, also, actually the cycles also increased. Here we have, one cycle. Here also one cycle, but here we have a cycle with some branches. Here the branch is already completed. We have two cycles, and here we have actually several cycles. So with the increase the number of the atom, we will have a complex mixture. Okay, so for example, what is happening for in wax or in asphalting. So this kind of material are of a great importance for us to so there are several physical properties also that you need to understand. For example, what is the temperature or pressure that that this kind of cycloparaffin will be appear. That's why in flow assurance studies, which is one of the branch, multidisciplinary branch, together with petroleum engineers, chemical engineers, and also mechanical engineers. So we have a flow assurance. So in flow assurance, there is one term such as wax appearance temperature. So WAT. So what is the temperature that wax will be appear there? So that's why there are several terms associated with knowing this kind of information that are very helpful in actually determining a safe transport of hydrocarbon to the sale point. Okay, so this is aromatics. This is the basic building block of hydrocarbon is benzene ring. So this is benzene ring, and then the aromatic structure occurs especially in a high molecular weight fraction of petroleum. So this shows you a benzene. Normally this schematically shown as like this. So, and also this is an toluene. This toluene also shown like this. The two compounds shown above are common aromatic constituents of petroleum. So, for example, we have volatile, petroleum compounds. So this kind of this kind of hydrocarbon is very important and normally will be utilized and will be used in petrochemicals for different purposes, for plastic manufacturing and other. Okay. So this is 9 hydrocarbons. So 9 hydrocarbons in this group contain nitrogen, sulfur, and oxygen. Okay. So free nitrogen gas may be generated during the formation of petroleum. So sulfur organic compounds are often full smelling. The best known is H2S. So H2S is here is very, very important in in production of oil and gas. Sometimes the presence of this H2S will increase the precipitates of other kind of so this H2S will directly act toward precipitating of some components in petroleum that will increase the chance of having asphalting and wax in our system. So that's why the effect of each of these impurities in our hydrocarbon production and transportation is very important. Oxygen compounds include alcohols, ethers, and organic acid. So just one for